The first chi-square test we will discuss is the goodness of fit test. We use the four-step hypothesis testing process with nonparametric tests. However, the hypothesis we frame in step 1 is articulated differently. Instead of hypothesizing about population differences or relationships with chi-square, we hypothesize about population proportions. As is stated on the slide, the chi-square goodness of fit null hypothesis would state that the proportions per category from our sample data is no different from the proportions per category that we would find in the population. The graph on the slide is figure 15.1, also shown in page 512 in your text. It shows a distribution of grades for a sample of n equals 40 students, with the same data expressed three ways: a bar graph, as a table, and with frequencies in a series of boxes. In particular, we're not measuring a numerical score for each individual. Instead, the individuals are simply classified into categories, and we want to know what proportion of the population is in each category. Specifically for chi-square, we organize and summarize our data in the rows of cells as shown on the right of the slide. For the chi-square goodness of fit test, we must calculate the hypothesized population proportions, the expected frequencies, and we have two methods we can do that, depending upon the information we have. In the first method, the no preference method, if we have no information available about what proportions exist in the population, we distribute the proportions equally across however many categories we have. So for example, say you wanted to determine the hypothesized proportions for a sample of 100 people with respect to choice of cola beverage. You have four categories of cola beverage: Coke, Pepsi, RC, and generic. And you have collected data from your sample of 100 people about how many of those people preferred one cola beverage over another. But you have no information about what the proportion of population beverage choices are. So you would distribute equally a proportion percentage across the four categories that would add up to 100%. In other words, the hypothesized proportions for the population would be, across the four categories, 25%, 25%, 25%, and 25%. In the second method, the no difference from a known population method, you do have access to population proportion percentages, and you start with that. To use our same cola beverage example, say that you do have information that says that 40% of the population prefers Pepsi and 20% prefers Coke. You would start with that and then distribute the remaining 30% equally across the RC and generic categories, so each would get 15%. To prepare your data for the formula, you organize it into the single row of cells, and the counts per category from your sample are the observed frequencies. If you are not given your sample size, n, in the story problem, you can easily determine that by summing your observed frequencies. Depending on how you calculated the hypothesized proportions, using the no preference or the no difference from a known population method, you then use that proportion in the expected frequency formula shown on the slide. Because you don't use the hypothesized proportion in the formula, you need a hypothesized count per category. To calculate that value, multiply the proportion by the sample size, or n. Based on the results of the chi-square test statistic you compute for a goodness of fit test, if your sample statistic exceeds the critical table value, you reject the null hypothesis and conclude that the proportions in your sample data differ significantly or are not a good fit with the category proportions found in the population. If your test statistic does not exceed the table value, then you can conclude that the proportions in your sample data are what you would expect to find in the population. To use the chi-square table, you need to first calculate degrees of freedom. For chi-square, sample size is not part of the degrees of freedom formula, only the number of categories you have. Click on the link to a worked example of the chi-square goodness of fit test located next to the video link to see the formula in action.